All right, y'all. So in this video, what I want to do is look at equilibrium. Some situations that are in equilibrium, some that are not. Really what we're looking at here is the balance of forces. All right. So what I'm hoping to do is go through a couple of examples. Most of these I assume that you'll probably be able to do on your own, but I just want to make sure that you have somebody talking you through it just in case this is all still very new to you. All right. So we're just going to go through each of these questions. I have 8 total questions, 4 questions with 2 parts each, and we'll go through and work through each of those and make sure that we're okay with whatever's there. All right, so here's our first one. Our first one, the question is to calculate the force required to balance the forces. So that means an equilibrium state. Remember that balance the forces means that the horizontal needs to balance and the vertical also needs to balance. And so with a lot of these, that's going to be kind of our main goal. All right, so in this first one, we notice that we have 60 to the left and 60 to the right. Now, what that means is that those two balance each other out. Those are the only 2 horizontal forces. They balance each other out. They cancel, so they're good to go. Now, I have an upward force of 40 and an unknown downward force. Because that's the only other force available, then that's going to have to be 40 newtons, right? Now, if I were to write this out, I'd put a positive for the up and a negative for the down. And so when you add those together, the positive and the negative add together to give you 0, which then balances the forces and gives you 0 net force. And that's it. All right. Now, in letter B here, it does get a little bit more complicated just because it does give us an angle for some of our forces. Now, all that means is that we're going to take those forces. So I'm going to take this one over here on the right. So that force goes up in this direction. I'm just going to rewrite it because it'll be helpful for me to visualize. So that's 40. And then I've got an angle of 30. So that would be, I want to break it into the vertical and the horizontal because adding vectors at angles is quite challenging. You do need some upper level mathematics in order to be able to do that. So to simplify, we're going to break it down into its horizontal and vertical pieces, this being the 30-degree angle. So first I'm going to look at the vertical piece, which is the adjacent side to the angle here. So I'm going to go cosine of 30, because that's my angle, is equal to the adjacent side, which that's my unknown, divided by the hypotenuse, which that was 40. Sorry, I should have put the 40 over on this side. I guess that would have made sense. So over 40. So cosine adjacent over hypotenuse. And from there, we just solve, right? And so I'm going to multiply by 40. So I'm just going to go 40 times cosine of 30. Make sure that you're in degrees, by the way. If you are in radians, that's going to mess your answer up. But I do end up getting that y equals 34.6 newtons. All right, so that's going to be the vertical piece here is 34.6. And I also want the horizontal piece, so that's the opposite. So I'm going to do the opposite over the hypotenuse. I'm always going to refer back to the number that was given when possible. I'm not going to use tangent. I'm not going to do opposite over adjacent because I rounded that number. I don't want to have to mess with it. So I'm going to go sine of 30 equals the opposite, which is the horizontal, over the hypotenuse, which was 40. And so again, I just go 40 times sine of 30, and I end up getting that x equals 20. All right. Now, what you'll notice is that over here on the left side, I have another 40, but that one also has an angle of 30, right? And so it's going to have the same vertical component. So it is also going to have a vertical component of 34.6. But then its horizontal component is going to be 20, but it's going to be to the left. And so when we add those together, again, the positive 20 and the negative 20 are going to add together. Those are going to cancel out. So my horizontal components, those are going to add together and cancel out. So now, if I'm trying to find F here, I just need to find out how much total upward force do I have so that I can balance it with this downward force. Now the total upward force, well, I got 34.6 for this one, and then I also got an upward of 34.6 for that one. So really I just need to add those two together, and so I'm going to go 34 0.6, and I get 69.2. So F then needs to equal 69.2 newtons. All right? It is downwards, so if I were going to do this in some type of equation or something, I would make it negative to represent the fact that it's down. But in this case, we're fine with just going 69.2 because we can visually see that it's going down there. All right? So we've done the first couple. Let's move on to the third one. The third one, we actually did this in class, but we'll go ahead and talk about it right now. The question is find the resultant force. What that is that's the net force. Okay, we often use that term instead, the net force or the total force. And so this is as if I had three different forces pulling on this object right here, one up to the left, one down to the left, and one to the right. What would happen to the ball? What would be the total force? What would actually occur? What would happen to that ball? So that's what we're going to figure out right now. So similarly, just like what we did up here, we are going to take the time to break these into components. So I'm going to do the top one first. So that one is going to break into a horizontal component like that and a vertical component just like that. So I'm going to do the horizontal one first. Okay, that's adjacent. You can tell that for some reason my brain likes to do the adjacent side first. I did the y, which was adjacent here, but this time I'm going to do the x, which is adjacent. So notice that the x is adjacent to my angle. So that's going to be cosine of 20 equals the adjacent side, which is x, over the hypotenuse. Cosine is adjacent over hypotenuse. And so then I just type that in. So I'm going to do 50 times cosine of 20, which that gives me 46.9. So I'm going to do that as 47.0. All right, so that's going to give me the horizontal component here. Notice that this time I used cosine to find the horizontal. In the previous one, I used cosine to find the vertical, right? You'll look, sometimes when you look online, it'll say things like, the horizontal is always cosine, and the vertical is always, that's not true. You should look at the situation each time, see where the angle is located. It depends on whether it's down here or up at the top, and then use your amazing knowledge of right-hand trigonometry to determine whether you need to use sine or cosine. Okay? Now in this situation, I'm now going to find y, the vertical component. In order to do that, that's going to be the opposite over the hypotenuse, which many of you already know that that's going to be sine. So sine of 20 equals the opposite over the hypotenuse. And so that's going to be 50 times sine of 20. And that would give me that y is equal to 17.1. All right. So now that I have y is 17.1 and x is 47.0, I can go back to the picture. Notice that again, the bottom one is identical to the top one. So it's still going to have that leftward force of 47. It's going to have a downward force of 17.1, right? The angles, and that's not going to change. All that's going to change is the fact that this one is going to be downwards now. Okay? So with that, we should then be able to say, well, the vertical forces are going to cancel. Those are going to balance. So now I have just this force to the left. I have force to the left from the up 50, and I have force to the left from the down 50. And so each of those are 47. So I'm just going to take that 47, and I'm going to add it to itself. I'm going to get 94. So there's a total of 94 to the left, and there's a total of 20 to the right. Now, if you want to see what this would look like, I would say the sum of the forces would then be equal to the 20, which is to the right, minus the 47. Sorry, I wrote 44. I was thinking and said 47. So the 47 is this one to the left, minus another 47, which is this one to the left, right? The horizontal component of that. And so if we were to do that, then we would write it this way. It would go 20 minus 47 minus 47, and we get negative 74. So the sum of the forces, or the resultant force, or the net force, is negative 74 newtons. In other words, 74 newtons to the left. All right? So not too bad, right? We can handle this. We can handle this. The math isn't too bad. You just got to see it a couple of times, right? Okay, let's go ahead and look at number 4 here. In number 4, we've got a 40 Newton to the left, we've got a 60 Newton to the right, and then we've got a 40 Newton upwards. So when I look at the vertical forces here, the only one I see is the 40. So I'm going to note that down. So my vertical net force is just 40, okay? Now, the horizontal is going to be the combination of these two, and many of you look at that and you already know it's going to be 20 to the right. If not, that's fine. What you do is you just go horizontal equals negative 40 because you got the 40 to the left, and then plus the 60 because it's 60 to the right. And when I add negative 40 and 60, because it is a summation, I end up getting 20 newtons. Because it's positive, the result is positive to the right. Now, I'm not done because the question is to find the resultant force. Force is a vector, which means I need both a magnitude and a direction. So what I have now is I have a vertical force of 40, which is this, and I have a horizontal of 20, which is that. What I want, though, is I want this guy right here. This is the net force. This is the result of adding those things together. And so I'm going to need to go a squared plus b squared equals c squared. All right, so I'm going to go 40 squared plus 20 squared. Okay, that gives me 2,000. And then I'm going to square root the 2,000, and it's going to give me 44.7. So that's the magnitude. I also need the direction. Now, it's usually best to give the direction with respect to 0 degrees. 0 degrees is always the horizontal x-axis here. So that's going to be what I'm looking for. All right, this angle right here. I do have the magnitude, but I need the angle. The easiest way to do that is probably going to be to get this angle first and then subtract it from 90 to get that one. Okay? And so we're going to use, I'm going to use opposite over hypotenuse. So that's going to be the tangent. So I'm going to go tangent of theta is equal to the opposite over the hypotenuse. So that's 20 over 40. Many of you already know what that is. But if I go 20 divided by 40, I get 0.5. And then I need to move the tangent to the other side. So I'm going to do the opposite tangent, the tangent inverse of 0.5, and you'll notice that if I do the inverse tangent of 0.5, I get 26.56, so 26.6. So my final answer here is going to be 44.7 newtons at, now remember that angle is this one up here, so I'm going to subtract that from 90, and I'm going to get 63.4. degrees. All right, so there we go. We've managed to answer the 4th question. All right, whew. Okay, let's move on to the next one. The next one here. Okay, now we talked about this one a little bit in class as well. Actually, we talked about this a lot in class. Remember, when you have something that's at an angle, when you have something that's on a slant, it's going to be valuable to take that and we're going to look at it sideways. So we're going to make our x-axis be this way, and we're going to make our y-axis be this way. Okay? Notice that my x and y are still perpendicular to each other. That's important. They must be perpendicular to each other. And so when I look at that, I'm going to have this force, which is horizontal now. I've got this force, which is vertical. This force, which was straight down, is now at an angle. That now has both a horizontal and a vertical component. So the vertical component would be going down this way on the y-axis. The horizontal component should be parallel to the x-axis here. So that would be this way. Notice that this and my x-axis are parallel to each other. All right? And so therefore, I do know that this angle is 30. Okay? This angle down here will always be the same as the angle of your ramp. There's a whole bunch of ways that you can prove that. The easiest is to say, well, y used to be straight up and down, as I tilt my ramp, y gets moved over. The angle that I move y over is equal to the angle of the inclination of the ramp because I have to rotate it 30 degrees. I go from here up to there, so therefore I rotate from here to there. It's 30 degrees. You could prove it geometrically as well. You could use a right triangle and all sorts of fun things in order to prove that that is the same angle. For now, we're just going to run with it because I want to make sure to be able to get through each of these questions. All right? So the question, of course, is by resolving into components, calculate if the following bodies are in translational equilibrium or not, and if not, calculate the resultant force. All right, so we're going to then break y. Y is 10 newtons there. 10 is the hypotenuse. We need to break that into the horizontal and vertical components. All right, so I did this very slowly the first couple of times. This is now the adjacent, and so I'm going to use cosine. So I'm going to go 10 times cosine of 30. If you're uncomfortable with me jumping straight into the 10 cosine 30, please take time to do what we did before, right? You can write it out. Write down cosine of 30 equals adjacent over hypotenuse. This is the adjacent side. This is the hypotenuse. So you can do that. That's fine. But in the interest of this video, I'm going to shorten the trig stuff now. If you need practice with trig, this probably is not the best video for that. Okay, so I ended up getting the vertical is 8.66, okay, which that's negative because that's my negative y there. And then I also need the horizontal component, so that's the opposite side. So that's going to be 10 sine of 30, which is going to give me 5. Okay, so what we end up seeing then is this. Is we see that the vertical according to our new XY plane, the vertical forces balance, right? They cancel each other out. Okay, that's good because if we did have a block on a ramp, this is essentially a free body diagram, right? You got the normal force of the ramp, you got gravity pulling down on the block, you've got some friction there. This is just a free body diagram, right? Looking at all the forces acting on my block. Well, if that's the case, the block, according to my XY plane, it accelerates in the x-axis. It does not accelerate off the ramp or into the ramp. So the vertical forces here should balance. And they do. I got 8.66 and negative 8.66. Those two cancel out. So now all I have to do is look at my horizontal. So I've got 5 this direction to the left, and I've got 1 up that direction. And so what I end up doing is I subtract those two, and my final answer is 4 newtons. And then I'm just going to call that a negative 4 in the horizontal direction. Okay? Now, there's a whole bunch of different ways that you could define that angle, right? You could define it in terms of its actual angle there. You could say that's in the negative x direction. There's a whole bunch of different ways you can define that. As long as you are clear, I've defined this as my horizontal. So by saying negative 4 horizontally, it's clear that I'm going to the left. That's also clear with the work that I've been doing. I would define this 5 to be negative as well because that is to the left. That would then be consistent with everything else I've done, and that should be fine. We're good to go. All right? Let's look at this other one. Okay, very similar. Now, this one is not as clear that it's a block on a ramp, but you'll notice that I do have a 90-degree angle there. Because I have a 90-degree angle, I'm going to go ahead and define this as being x and this as being y. Okay? Now, this one, I don't have the angle of the ramp, but I do see that this vertical line and my new y-axis, those create a